I'm just gonna do this 2D. We do a 2D project, call it Pong. I always put projects in my external drive and a Unity project folder. I'm using the latest version of the LTS right now, so let me see here. There we go. Finally, I think we're gonna get somewhere. Finally. Okay, here we go. Unity is up and running. Finally. So we have a 2D project. Let me just put that like this. Still compiling. Burst. If I just go back to here, let me just look at and see how large it is. It's 1 gigabyte. All right, so we got our create a new scene and call it main. So that's what I'm going to do first. We are going to, it already has a scene folder, so create a scene called main. I don't know, I'd like to do it this way. Delete sample scene. So we're in the main scene. It has a main camera. It's a 2D project. You can right click and move it around if you want. And then we want to change the camera to solid color, background black, size 300. That will zoom the camera way out, I think. And the viewport rect 800 by 600 because this is converting from a Python version I had. It was 800 by 600, so I'm doing the same here. So we have that set. And right now I have nothing, of course. 800 by 600 screen. In the game view, we want to change this to 800 by 600 by creating a new profile. And change 800 by 600, fixed resolution. Okay. So we're in 800 by 600. And let me save that. And I save often because this laptop sometimes blue screens on me. So save early, save often. Okay, create some folders. Scenes, I don't have to create that. I guess I can delete that from the thing. Okay, create some folders. Materials. Prefabs. Scripts. Sound effects. And scenes we already have, so. Okay, the drag your main scene, okay. That's already done. 2 sound effects for the game. You can get them at freesound.org, so we have these 2. And I need to get in here. So I'm gonna go, well no, I already, in this one I edited down with Audacity. So anyway, I'm gonna go to freesound.org and get that one. Might as well edit it down in Audacity to the other one. This one is fine. That's all I'm looking for is a score. Gotta log in and then download score1.mp3. I'm gonna put it directly in the folder. then the other one is this one. I'll download that one. I'll put it in the same folder for now. It's gonna have to be edited because it's too long for what we want. This thing I just want one of these. Not that one. Not that one. I'll just take one of these, basically. It's too bad you can't select what you want here, but that's what we need Audacity for. So do I not have Audacity installed? I guess I don't on this computer. So if we go to Audacity, audacityteam.org, you can download it. I don't know, I thought I had it installed on here. 64-bit. Downloads. I don't know what it's doing. We'll open that. And it will launch. So we don't need this anymore. We don't need this anymore. I'm going to open that file. Actually, let's see. We want to open this show in folder. I think you can maybe drag and drop it. Drag and drop in. You can drag and drop into Audacity. So this is what we just want to do this. Not that one. That one there. This one here. This one here is fine. Like this. Basically, that's what we want. So we want to copy that, create a new, and paste it in. Selected audio. And then what we're left with is like 1/10 of a second. That's all we need. So we want to export that as, we can do wave, Pong. So we just want paddle hit. Yeah, it was called paddle hit dot wave, I think. No. No. All right, so we got the paddle hit wave. We don't need this anymore. So we have to go back to Unity. Okay, so you can drag and drop them in, or you can download them in directly, and now they're here. So let's look at this. And we got score 1. Good. That's done. We'll use those later. Not going to use them right away. Those right near the end, actually. So now we're going to create some game objects. So we're going to create UI Text Mesh Pro. We want to import the essentials. And then don't need the extras. Close that down. And then we will do F to frame that. And what we want to do here is put this in the center. So we can do Alt Shift, Alt, or just Alt, and then frame it. Zoom out. So it's called game over text. And we will position it in the center of the screen, give it a size of 72 points. I'm going to put game over as the text. And we want to put that centered, wrapping disabled. So, still sounds good. That's all we need for that. So, game over text. Why is it like that? I think if you do this, Alt Shift, no, for some reason, this is smaller. Like, okay, so let's make it bigger. Just do that. It's centered right now. We're gonna readjust that later. We need to disable that for now. We don't want that showing in the game. That'll be enabled later. Paddles. Now we'll create the paddles. Some 2D object sprites. So let's create. Not well. That. 2D object sprites square. Call it player. And it's going to be 15 scale, 15 by 75, and positioned at 50, 300. And if we select completely, it's way over here. Why is that over there? Because, wait a second. Why is it up there? So for some reason, oh, see the camera is, why is the camera, change the size, no. The camera should be, oh, where it, let's see here, can I move the camera? Let's see, we need to move it so that it matches. I don't know why it was way off here, but I'm not sure why it is actually, but, or something with this, I don't know. So if your camera is off, you can position it so it matches 400 by 300. That would be exact. Okay, so that's fine. And then the game, it'll show up like that. Good. Next, we're going to duplicate this. Control D. Call it AI. And we are going to set the position at 750, 300. And now we've got our enemy AI. And we're going to duplicate the player one more time, call it the ball. The ball is going to be only 10 by 10 at 400 by 300, right in the center of the screen. There's our ball. Some tutorials make the ball round, but I think the original Pong, it was square, from what I remember anyway. And then on the ball, we want to add a box collider and a rigid body. So we go to, let's type in collider, box collider 2D, and a rigid body 2D, rigid body 2D. The properties, the collider should automatically have the, if I zoom in on the ball, it should automatically be, the box should be perfectly aligned to it already. So okay, and the rigid body, we want to turn off the gravity because we don't want the ball to react to gravity. And the freeze rotation Z, we also don't want it to be rotating. So we only want it to move in X and Y, not in Z, just in case. Okay, so now on the player, we wanted to add a box collider and a rigid body to them as well. Box collider 2D and a rigid body 2D. Gravity scale of 0. Okay. And enable freeze position X and Z. And for the player, actually Y, because we're not using physics to move the player up and down. So we don't want any automatic physics to kick in here, because at some angles the ball will hit the paddle and cause it to slowly move up by itself if you don't have freeze position Y on for the player. For the AI, it didn't seem to have that problem, so I didn't need to. So I put a rigid body 0, freeze position X and Z. You could probably freeze it in the Y as well, because we're not using forces to move it. And then, yeah, so add a collider as well. Box collider 2D. Shouldn't need to do anything. So we want to create a physics material for the paddles, and otherwise the ball won't bounce off correctly. It'll just stick to the paddle, like it'll hit the paddle, and it won't be good. It won't be good. So we will create in the materials folder, create a 2D physics material 2D and call it paddle physics. Bounciness of 1, friction to 1. I find that the friction, you can change the friction, but the bounciness 1 is essential to get it to keep moving as we want it to. So friction, you can experiment with. I chose 1 for now. It seems like it's more dynamic. The more higher the friction is, the quicker the ball may bounce off. So it might create more action on the ball. You can experiment with it. I had it to 0. It doesn't. The ball just keeps going back and forth. Okay, so now we're going to apply this to the player and the AI in the rigid body. So we go to the rigid body 2D. We can click this target and double click paddle physics for both. Okay, save the scene. Okay, and now we're going to have 3 scripts: player, AI, and ball. So let's create 3 scripts. Player, AI, okay. Wait till the script compiles. AI, and ball. So we want to open the ball script. Oh, you can copy. This is a good add-on for WordPress, by the way. It's the Code Pro. So let's see. So we want to open the ball script. First of all, let's just apply these. You can either drag and drop. I like to do that. You can drag and drop. Sometimes it doesn't work. So in that case, you can go add component, script, ball. You can just type in the name of your script. And it will add it. And then the AI, let's do that. See if it's there. It is there. Okay, open the ball script, double click. Visual Studio. First time it loads for the new project takes a little bit longer. Just gonna put it there. Okay, good. And add this code at the top of the script. This is for the speed of the ball. And this the serialize field will let it show up in the inspector. So if we go back to the inspector and look at ball, it's going to create a speed X and a speed Y. So we can change this. So negative 20 minus 20,000. It seems a lot, but that's how it was when because this is the amount of the force it's going to add. And speed Y to 0, so that's the initial speed. And you can adjust that. And then we're going to add this under these variables here. A rigid body for the ball. It's a reference to the ball's rigid body. And in the start method, we're going to copy that and paste. We have to get the component, store it in the ball RB, and create a new vector2 force with the speed X and speed Y. And then we're going to add force to the ball. And this will set its initial motion. So we can test this out and see if our colliders are working. And press play. And it bounces off the paddle. And it's going to keep bouncing forever. And we don't have any motion yet, so on the paddles. So it will move and it will bounce off the player and AI paddles. There's no code involved to handle the collision and the ball movement except adding the initial force to it. So it's working as intended. But of course it only bounces back in the Y. I chose to add a random force to the ball, a Y force whenever it hits the paddle. So let's add that. I'm going to add another serialized field for this force range. Set it to 100 to start with, and then we're going to add to the collision, on collision enter to the method, the automatically provided by Unity method that will get invoked when the ball collides with something. So what we're going to do here is set a random range between minus 100 and plus 100, and add a force to it in the Y direction, create a vector2, and then add that force to the ball. So save that. And then we get a random Y direction when it hits the paddle. We can see if that works. And you may not see a little bit in the Y going down. If I increase the range, I can maybe get it to be more obvious. Minus 1,000. See, it's going down now. Let's go. Try 10,000. Yeah, see 10,000. See that? Yeah, it's gone now. Awesome. So maybe 10,000 actually. You could use it. And of course, yeah, well, that's a lot. That's a lot. It's a lot. Yeah, but that's another thing you can play with, right? So that's because it's easier to do that than for me to write some code that checks where the ball is in relation to the paddle, because you could write some code that checks if the ball is on the top part of the paddle, then you want to reflect off this way. If the ball is on the bottom part, you can reflect off that way, or if it's in the middle, you reflect this way. But I didn't write that code for this tutorial, so I'm not going to do it here. So all right, so we got that done. So right now we're going to make sure the ball cannot go off the top and bottom of the screen. We want it to bounce off. So what we're going to do is take the physics and use that to our advantage and create some barriers here, some barriers. So we're going to create another sprite, a square called top wall, and 400 and 605. And we want to scale that to 800, so the width of the screen, and 10 is fine. And it is right at the top here. And now, is it visible in the game? No, it is not. So it's right off of the screen, right at the top edge of the screen. And so we want to add a box collider to it as well. Box collider 2D. And we'll put the material to the paddle physics as well. So it bounces off that wall the same as it does with the paddles. And then we want to duplicate that and for the bottom. And we'll put that one at 400 and minus 5. So they'll just sit off the edge of the screen. They shouldn't be visible. No. And it will prevent it from going off screen. So we can actually, maybe with that 10,000, we can see if it goes off, tries to go off the top of the screen there. And if it will bounce off, yes, it bounced off. Okay, good. No code involved there, just physics. And now if the ball goes off to this side, it will keep going forever, and you'll still see it in the editor. Watch it. It's gonna keep going, and the position will keep going forever. And if I do this, there it goes. So let's prevent that from happening. Let's get back to our scene here. Okay, so we go back to the ball script, and in the update method, add these two variables first. Left and right bounds. Iron Hearts, that was Julia. She was watching, okay. All right, so left bound, right bound 0, right bound 800. So if what we want to do here in the update method, I'm just going to replace the whole thing, is if the ball's transform goes off the left side of the screen, which is 0, then it destroys itself. Else, if it goes off the right side of the screen, which is 800, it will also destroy itself. So want to make sure that if the ball's position is at 0, it's on that side. If it's at 800, it's on that side. So let's put it back to the center. So if we it's gone now. It's gone. It doesn't exist anymore. Okay, so it will destroy itself now. Now we're going to put in the AI logic. And we're going to use the same AI logic that I did in the previous Pygame version of this. It will attempt to match the Y position of the ball. So let's open the AI script. And add these 3 variables and a reference to the ball prefab, which will enter into the inspector. Actually, we won't. It will search for that. Float paddle speed is 5, top bound 560, bottom bound 40. Just so that the AI, because I found the AI will go off the top and the bottom of the screen unless we prevent it from happening. So what we want to do here in the start method is find object of type ball, game object, find object of type ball, and this should work. Cannot implicitly convert type ball to Unity Engine game object. For some reason this code worked before, so I'm not sure why this isn't dot game object. Yep, that's one way to solve it. Just access the ball's game object component, which is, every game object has. So that's going to be that. And then, so if you get that error, just add that to it. I'm not sure why this worked before. I don't know. I don't get it. But in the update method, it could be based on what version of Unity. I don't know. Anyway. In the update method, we want to add all this code here. So what this does is, if it's the prefab, if it can't find the ball, then it will search for it. And then if it finds it, if it finds the ball, because if you need to do this, because once the ball at the start, it'll be there, but then the ball goes off screen and destroys itself, and it gets re-instantiated, then it won't have that reference anymore. So we have to get the reference in the current ball. And then if it's not null, then we want to get the center of the ball and the center of the AI's paddle using the sprite renderer bound center Y. And then we're going to attempt to follow the ball's Y position. So if the center, our center of the paddle is less than the ball Y position, then we're going to increase the paddle up in Y. Otherwise, we're going to go down in Y. If it's less than, if we're higher than the ball, we go down. If we're lower than the ball, we go up. And using the paddle speed times time to delta time to account for the, to get a constant frame rate. And then paddle speed can be adjusted in the inspector. So we're just going to try and follow the ball up and down. And we want to prevent the AI from going off the top and bottom of the screen. So we're going to add this as well. So if the position of this paddle goes greater than the top bound, then it's going to be equal to. So we're going to create a new vector2 because you can't set transform.position.y directly. So you have to create a new vector2 with the existing x position and the new y position, and then just put it back to the transform position. There may be better ways of doing it, but this is how I'm doing it for now. And then we're just setting it equal to the bottom bound so it doesn't go below that. So this is basically all you need for your AI. I think, I don't know if this is going to work right away, but because the ball we haven't converted to a prefab yet, but let's just check it and see if the AI tries to follow it. It is trying. Like the speed is only 5. So if I set the speed like to something higher, let's try 20, 30, 50. I don't know, 50. Try that. Okay, it's, yeah, a little bit faster. You have to experiment with these values. Try 100. And we have a null reference exception here, so let's see it in AI. I believe it's trying to find the ball. I don't know. We're not going to have to worry about that too much right now because it's line 29. We'll look at that. But it is finding it because it is able to try and follow the ball. So the line 29 is this, where it's trying to find it. We'll worry about this later because the ball is going to be a prefab, so we may need to change this too. So let's implement player movement now. So let me open the player script. And we'll add these variables. Our paddle speed is 10 float. And the same top and bottom bound because we don't want the player to go off the top and bottom of the screen either. And in the update method, we want to check for the W and the S key. So if the input is W, if we're holding it down, get key is if you're holding it down. If the user is holding down the W key, it'll go up. S key will go down. So the paddle speed, and then it'll just create a new float and then a new transform position with that new position. It's basically the same movement speed the AI uses, just we're checking for key codes instead. And we want to prevent the player from going off the top and bottom of the screen. So we'll do this as well, basically the same code we put in for the AI. So now we should be able to control the player's movement. So let's test that out. It's very slow. The speed is too slow. So let me change that, say 100. You have to experiment with this to see. It's a little slow still, maybe 200. Maybe 200 is better. Oh, there we go. That's a little bit better. I think I had 200 when I did this. There we go. Now we got the AI is hard to beat with this because and you can play around with the AI's paddle speed to see how it hit and it I missed. Okay, good. So that's working. Now we're going to create the ball prefab. It's going to be a prefab that's instantiated at runtime. So what we're going to do is we are going to just drag it into the prefabs folder, and it's going to turn blue, and we're just going to delete it from the game because it's going to be instantiated at runtime. So we're now going to add a game manager. So to keep track of the score, instantiate the ball, and detect when the game is over. So we're just going to create an empty game object, call it game manager, and a script called game manager. Let that compile. And you notice that Unity changes the icon to this little wheel, or it looks sort of like a saw blade or something. I think it's supposed to be like a settings icon. It just recognizes that Game Manager is a special type of script, although it's not. We're not using singletons here or anything like that. So, you know, all it does is change the icon. It doesn't do anything other than that. So we want to attach this script to the Game Manager object. So we can click that, drag it in, and add the script. Save. So now we're going to use the events to manage scoring. So the ball is going to raise an event when it goes off one of the sides of the screen to let anyone who's subscribing to it know that there was a score done. It was scored. So then the game manager will subscribe to that event, and then it will update the score and respawn the ball for the next round. Otherwise, you'd have to have your game managers, in the update method, just continually checking to see where the ball is to find out if there's a score. Whereas with events, it doesn't do anything. There's no code executed until the ball itself tells someone that something happened. So, and then the game manager will be just alerted when that happens, and then it will act accordingly. So the observer pattern, it's called. So we'll have the ball generated event. So let's go back to the ball script. And we're going to add these things here, which is we're declaring a delegate called score action. And it's going to take a string of side, which will be left or right, depending on which side the ball goes off, and an event called score of the same type called onScored. So this sort of defines the signature of what the subscribing event needs to look like and what it will expect a parameter. So, and then the actual event onScored, it's going to be called by the ball. So, and they're public, have to be declared as public so that other objects that need to subscribe to them can do so. Note that nothing has to subscribe to it. In that case, onScored is null. So when we're erasing the event, we only need to raise it if onScored is not null. All right, so add this to the update method here. Okay. So we're checking here if the ball goes off the left side of the screen and if on scored is not equal to null. So if someone is subscribing to the event, then it's going to raise the event by calling on scored with the left parameter, and then it will go ahead and destroy itself. Otherwise, if it goes off the right side of the screen, if it's in the same thing as null, and then we're going to call on scored right with the right side of the screen, destroy, and then destroy itself. It's just simple, super simple. This is as simple an event system as you can do, I think. So interesting how this looks different, but it still pastes in fine. So all we have done, yeah, so now we just need to subscribe to that event. So the game manager needs to subscribe to the event. And we do this in the onEnable and onDisable methods. These are provided by Unity. So when this game object gets enabled, it will subscribe to the event by calling this the ball's on scored and add itself. So it's basically the ball is keeping a list of subscribers. So it's adding itself to the list of subscribers that the ball has. And on disable, so when, say, the game ends, you turn off you exit the game, it will minus equals it so that it unsubscribes from the event, just so that you don't get memory leaks. If you don't unsubscribe, you can actually get memory leaks. So and notice we have this game manager does not contain a definition for onscored, because we have to now implement our method that's going to get called when the event comes in. So we need to implement that. I'm just going to add a couple of variables for the player score and the AI score. So we've got two variables for that. And then we have this is our subscribing method. So it has to be the same signature as the delegate. And we're just going to say if the side parameter equals left, the AI has scored because it went off the left side of the screen, the player missed, and else the player scores. So that means it went off the right side of the screen. And then we're going to update the scores and spawn the ball. So, which we don't have implemented yet, so we need to implement those. So let's see. We'll add a spawn ball, which will instantiate the ball prefab. The ball prefab is already set to this position, so whenever you instantiate this, by dragging it in, that's going to instantiate. It'll be in the center of the screen, and at runtime it'll be in the center of the screen, and it will invoke its start method to start the movement, so it'll start moving as well. So we have this reference to the prefab. We need to tell in the inspector or the game manager what prefab to instantiate. I didn't save that, did I? So until that compiles. Oh, it's not going to compile because we don't have update scores. So let's do that. Let's just do that first. So we'll add this. And then we can do the update scores method. And so all we're doing here is we're going to have two text fields on screen so the text will be updated with the score So it's already keeping track of the score here, which are integers. And then, so this is going to display them on the screen. So this should compile now. So we have the ball prefabs. We need to drag and drop the ball prefab into there. And we want to create these player score and AI score texts. So we're going to right click the canvas, UI, text Mesh Pro, and call it player score. We'll set it to 0. And let's see. Position them at, let's say 100. Now if I want to anchor it to the top left corner, so if I go Alt, it'll anchor it to there. And then 100 minus 50. 50. And you may have, for some reason, okay. No, we don't. Oh yeah. You put it wherever you want. Okay, so it's like 200 then. And then you can change the font size, maybe 72. Yeah, there we go. 72. And something like that. And then we want to duplicate this and call it AI score. And we will move this one relative to the right side of the screen and put that at minus 50. Minus 100 could be okay. So those will always be there. And then these are the objects we need to tell the game manager about. So the player score text is here, and the AI score is there. So we want to drag those into the game manager. Okay. Now, I'm still getting a null reference exception now. That's on line 29. Let's go back to here. I wonder if this is needed anymore. Let's see what it does with that now. Because this is now a prefab now. What if you call this ball? Then you don't have to do this, right? Maybe that's the private ball prefab. It is a ball after all. Let's see if that works. That may work better. Okay. Clear that. See if we get any errors here. Okay, there's nothing being instantiated yet. There was no errors. We have to okay. For some reason, okay. The game manager needs to instantiate the ball in the start method, I suppose. Because nothing's being updated. So when the game starts, we have to instantiate it. Okay, there we go. We'll see if the score updates. Yep, it does. He did score. Oh, that's good. I'm gonna score. Hey. Yeah. Okay, so that seems to be working. Oh, I don't know what's going on here. Yeah, let's see. That needs to be. that random force maybe is not too negative, basically. And sometimes it slows the ball down to nothing. So we can change that in here. If we want the, so the force range is probably too much. We could also put a, what's going on here? How come it's not? Won't let me go. It won't let me. Something's off with this. Maybe I double click that. Okay. It's 1000 maybe. And then we click there to save it. Let me save this. Anyway, we're not going to worry about it too much. So now, yeah, so it respawns right away. So I'm going to make the spawn ball routine a co-routine instead. So that, because spawn ball, all it does is just instantiates it right away. So like, because when we do it on scored, it does updates the score and spawns the ball. So in spawn ball, we want it to be instead a coroutine, so we can add a delay between rounds. So and get rid of this. So now we're gonna wait for 1 second, then instantiate it, then continue. And I mean, we can add you could also add a serialized field here for the round delay, and then use that instead of an integer, I guess, or a float. No, it needs to be float. Okay. And put that in here. Nope. Too much. Okay. There we go. And then you can adjust it in the inspector how you want it. There. Sure. There's an error somewhere. Oh, here. This extra. There we go. All right, so let's see if that works. I should wait a 1 second and then respawn after someone scores. Okay, there we go. And nothing. Why is it not working? Are there any? There's no errors. It's not working because we're not calling it properly. You can't just say spawn ball, I don't think. You have to do start, yeah, okay. Start coroutine, spawn ball. You want to start the coroutine, spawn ball, and you can do the same thing in the start method as well. So that it's initially we'll wait a second before it starts the game. Okay, yeah, there we go. Wait a second. So let's see. Okay, round 2. And with the random Y force set to only 1000, it's definitely less. You'll notice that the ball has less action on it. So that's definitely something to be played around with. Okay, but it's working. And the other thing you could do in that coroutine is you could like display a message saying round, do a round number, or say get ready, or anything like that before the next one gets spawned. You could do any types of animations in those coroutines or anything like that. So but for now, that's what we're going to do. And now we need to make a game over state. So we're going to keep track of when is the game over. So the game is going to be over when either player reaches a target score. And we're going to use events for this as well. So if the game manager detects that the game is over, it will send a game over event. And then the player and AI will be subscribed to that event. And in that event, it will just set their own game over state, their local game over state, so that we can turn off the controls and the AI controls. And then the game manager will also display a game over text. This game over text will come up, and a restart button we want to put in as well. So we're going to define this delegate in the game manager. And the game over text as well. And we've got a private is game over Boolean and currently set to false. And we've got our event game over. It doesn't take any parameters on game over. And we're going to update scores. We're going to come down here and say if the player score is greater than or equal to target score, or the AI score is greater than or equal to target score, then the game is over, and then it will send the on game over event to anyone who subscribes to it, and sets the game objects, the game over text game object to true, and the game over text is currently a text mesh pro GUI, so that's this thing. It'll turn it on. Okay, and then we've got on scored. We want to add this on scored event instead of. We don't want to respawn the ball if the game is over, so we'll replace that with this. So if the game is not over, then it'll respawn the ball on if a player scored. Because update scores will then update the game over state if it goes over the target. And we need to create this target score as well. So let's serialize field, integer, and we're going to set it to 5. So now we'll get rid of those errors. So now in the player and AI, we need to go in and subscribe to the event. And each of the player and AI will have its own local is game over Boolean. And they're on enable and disable, we're subscribing and unsubscribing. And the on game over will just set the is game over to true. And then what we want to do is use that here and wrap everything we already had into here so that if the game is over, you can't move. You won't be able to move the paddles. And we're going to do the same thing in the AI script as well. So we want this, use game over, and then we want to do the same thing here in this update. And there we go. So we don't have any logic running if the game is over. So now we're going to put the restart button in. So let's create a UI button. UI button, Text Mesh Pro, called Restart Button. We can change the width and the height like this, like that maybe. Say 160 by 60. And the position, we want to place it under the game over text, maybe. Turn that on. And I'll move this up. I'll move it up to here. And I'll move this up to here, say. That's good. And that's how it will show. And the text of that button can say restart. Okay. And then we want a method that it can call. So in the game manager script, we'll add a public method here called restart game. And all that does is reload the scene. Scene manager, load scene. All that does is reload the scene from scratch. And so if you're using Visual Studio, it automatically put this using directive in there for me. So you may, depending on what your editor is, you may or may not have to add this using directive. And this is a convenience, because otherwise you'd have to type in, Unity Engine, .scene management, .scene manager, and .load scene. So we're going to change this game over text to game over screen, and it's going to be a game. So basically, we are going to create a new game object, empty game object, called game over screen. And because I don't want to have to enable and disable these separately, I'm just going to put these as children to the game over screen game object, so that now when I move this around, both of them move, and it can be enabled and disabled with just one click instead. So that's what we're going to do here. We're going to make this a game object. And then we're going to rename it to game over screen. And in Visual Studio, it will go ahead and rename all the other references to it automatically. So game over screen will now be activated. And then, so that way we only have to activate one object instead of two. Let's see if it works, I guess. Make sure this is saved. Everything's saved. Okay. Just let it go till 5. 1, 2, 3, 4, 5. Game over. Except, you see, the variable game object. Yep, okay, so we have to. Can't forget to put this game over screen reference in the game manager script so that we'll know what that object is to enable. So and instead of going to 5, I think I can just change it. So you can change the target to 1, and then sudden death, game over. And then when we restart, it should restart. Okay, doesn't, because we have to hook up the button. So the on click list is empty, so we got to change the on click to the game manager and restart game function. Okay. Game over, restart. Yay, restart. So now it will work. So now all we need to do is add sound. Add our sound effects that we had way back when. So we want an audio source component to the ball prefab. So let's go to the ball prefab, double click that, add an audio source to it. And we're going to set the audio clip to the paddle hit wave and save the prefab by clicking this. And then in the ball script, we need to define that audio source. And in the start method, we will get the component. And then in on collision 2D, we will play the sound effect. That's all we need to do to implement that. And now we're going to add an audio source component to the game manager. As the game manager will play the other audio clip, the score one, whenever someone scores. So let's go to the game manager script and put in a reference to that audio source, and in the start method, get the audio source, and on scored, we are gonna play the audio right there, I guess. Now the sound effects will play. So let's test that out. Oh, for some reason it played at the beginning. Let's see. Okay, yeah, it plays at the beginning. Something is off with that. Okay, let's see what that's all about. And that's basically the only bug. On scored is where it plays it. We want to make sure that play on awake is not set. We don't want to play on awake. Otherwise, that's what happens at the beginning of the game manager gets instantiated, it plays the audio source automatically. And in the ball, we want to do the same thing. Turn off play on awake, because we don't want that to play when the ball gets instantiated either. So that should fix that problem. There we go. And if I lose, game over. Perfect. And then Let's set it back to 5, I guess. Target score 5. I want to change this back to, like, I don't know, 5,000. And there is some weird times when it hits at a certain angle that might be slow the ball down so much that the AI is pretty challenging, I think, because it's always following the ball. See how it slowed it down completely? That's a little bit of too much for me, but you have to play around with the settings. And we could put a lower limit on the ball speed in the code, I guess. But oh, so I bounced off into my own thing. That's fast enough, right? Just sometimes it hits at some weird angle and it slows it right down. But it's pretty good. So that's it for this tutorial. You can check it out on gameworldengineer.com. And oh, look at that. It's going straight up and down now. Let's see what happens. Super slow. See, that definitely is a problem. It's because of this -5. It's the Y force range. So if it goes too low, let's see. The random range that's using is, for some reason, adding a negative force. Too much in the negative direction, I think. But so I mean, you play around with this, or this code could be improved. But for now, that's where I'm going to leave it.